Hello, everyone. Thank you so much for joining today's very first session of the product and design theme here at Startup Slam. And thank you for joining us today for the session. This is called Challenges and Considerations of 3D Interactive Interfaces with Karina Rigby, of course. And my name is Amy. I will be the session moderator today. And if you have any questions throughout the session, feel free to add them to the chat, and Karina may adjust them as they come up, or we'll come back at the end to get them answered. So when Karina starts sharing her slides, as you can see already, you can actually double click on it. It'll expand into a big window so you detail text. This theme is sponsored by Gearbox, so a huge thank you to them for their support of Startup Slam. You can connect with them and learn more about what they do at the virtual booth today, anytime before 1 p.m. Before we begin, a little bit about Karina. So after getting an undergrad in computer science and visual arts, Karina stumbled into mixed reality software development, and she just cannot stay away. So in her spare time, she enjoys fitness, video games, and giving back to the tech community by helping those new to the industry through She Codes with Radiance. So if you have any questions about Karina's experiences or She Codes with Radiance, feel free to just pop them in the chat and we'll get them answered. Without further ado, Karina, take it away.
All right. Hey, everybody. Amy, thanks for the awesome intro. As Amy said, my name's Karina. And I have a Bachelor of Science in Computer Science and Visual Arts, and I've been working as a software developer at a place called Greg Marshall Naval Architect. It's basically, I'm working for a yacht design company, and I've had a lot of interesting experiences since working there, because for the first time, I started working with Hololens, and I'll get into that in a second, but it's led me to realize that there's some interesting findings to be had about developing for mixed reality and creating applications that are supposed to be experienced in mixed reality. So why are we here? We are embarking on the noble quest of making the best mixed reality experiences possible. So the question that we're trying to answer today is, what do mixed reality creators need to think about when creating a great experience? Well, first off, we want to make our experience, like our big goal is to make our users as happy as this one right here. You know, she's having a great time. So the three areas, here's the roadmap for the talk. The three areas that we're going to consider are immersion versus performance. We're going to be looking at the different input and output with mixed reality. And we're going to be looking at how to guide the user experience. And if we can address all of these areas, we're well on our way to making a great XR app. And that makes me about as excited as that baby right there. But first, before we get going, let's define what mixed reality is first. It's a spectrum. It's anything between like reality, like what we're in right now, all the way to virtual reality. So where everything is completely digital. So there's that in between where we've got augmented reality, where you have your real surroundings and then you're placing something in it, like Pokemon Go or your Snapchat filters or like the HoloLens stuff that I'll get into. And then it moves all the way over into VR, which is when everything is digital. So within mixed reality, you have screen experiences where you can use your phone or something to interact with, like you can use phone VR or augmented reality, like I said, Snapchat filters or something. Or you can look at, or there's headset devices where you can put the headset on and you're either in VR or something is being augmented into your physical space around you. So today, when I'm talking about mixed reality, I'm talking about these immersive experiences. I'm the ones when you're putting stuff on your head, because that's pretty different than designing for screens. So the first thing that we're going to get to is the relationship or struggle between immersion and performance. So first, let's think about a really cool mixed reality experience. This one is one of my favorites. It's a guy in VR and he's painting Easter eggs. So look at what's working well. We've got hand articulation. The assets look really nice. Everything's kind of, it's pretty sweet. It's behaving the way that he expects, or that we expect. Like his hands, when they move, it follows it, and that's pretty sweet, right? It looks really nice. Another one that is a great example of mixed reality is the HoloLens 2 demo here. And this lady, Julia, she's done a lot of work with HoloLens 2. And like, look at those hand interactions. She's using her hands. She's moving stuff around. She sees stuff in her space. It's behaving the way that she wants to. That's pretty sweet, right? Like, I want to get some of that. That's pretty awesome. So like, that's what we're aspiring to, right? Now, let's think about the other side. Like, when you think of a bad mixed reality experience, what is the number one thing that comes to mind? If you're like me, the main thing that comes to mind is motion sickness. It is the worst, right? Like, I've totally been motion sick in VR before, or even in HoloLens, and it's the worst. And technically, motion sickness, it's caused by, among other things, there's a number of factors, but one of the reasons is when the frame rate of your application is too low. And so we want to fix that. We want to try and avoid that, because when your apps have high frame rate, everything's peachy. The app responds in the way that your bodies think it should, and your brains are very, very happy. Like, you don't have to think about it. It's just natural. It's flowing. And that's what we're going for. But when apps have a low frame rate, it makes our bodies super aware that something very unnatural is happening. Like, if you duck and your environment doesn't duck with you, that's bad news, right? You're gonna feel not very good. And so if your app has a low frame rate and it judders, it totally breaks the feeling of being immersed in the space. And we don't want that. But so having a high frame rate is basically a key part to maintaining immersion in the worlds that you're building for your users. And so some sample performance targets are like, you have to keep your apps at 72 frames per second, or say with a Quest, like an Oculus Quest, and with the HoloLens, you have to go like 60 frames per second, which is fine, right? You might think, okay, yeah, that sounds pretty reasonable. Okay, of course I have to make my frames go that, or make my apps go that fast. Well, wait a second. Let's think about this for a second. Mixed reality devices work very hard. They have so much going on, and it's actually pretty amazing what they can do. They're thinking, like, they're processing incoming hardware sensor data. Like, for example, like, this is a Quest, and like, look at these cameras on the edges there. They're sending that out, and they're using that to find out where they are, like where the device is in space. It needs to think about hands and in some devices, and like what the hands are doing and where your head is and how it's oriented, and the motion that you might be doing, and predicting where you're going to go. Your mixed reality devices are going to be thinking about, they're going to be doing simultaneous localization and mapping, which just basically means, especially like if you're in a HoloLens or a Quest, it means that's the process or algorithm of your device determining what your space is around you and how your headset is oriented, what the rotation is. That's pretty impressive, right? And the other thing that your devices have to do is they actually have to run your applications that you write themselves. So, you know, thinking about stuff like, oh, if a user clicks this button, do this action. And it has to display something to the screen 60 times at least per second. And it's actually to two screens because you have two eyes. You have binocular vision, right? So that is a ton of stuff to do. And has to calculate what to draw to the screen. And it's a lot. And on top of that, you're trying to fit an entire computer into something that can fit on your head and not burn your forehead. And like, that's just a big deal. And if you're trying to also, if you're working with a device that is untethered, so it's not plugged into a computer, you're trying to do that, all that processing power, stick all that processing power into one device. So that's a big deal. You know, they're thinking about a lot of things. And so the truth of the matter is that mixed reality devices, like, yeah, they're always getting more and more powerful all the time. But as it stands right now, they're just simply not as powerful as PCs. And so we have to think about all of those things when we're trying to keep our frame rate fast enough and our applications fast enough so our users are having a good time. So what's one way that, or one of the things that we need to think about is 3D content. Okay, so our 3D content is what builds our worlds in mixed reality, right? We need to have 3D models and process them to make our worlds work. You can't have it any other way. Here's an example of Echo VR. Like, think about all of those 3D models that need to be built and all of the, like, that requires a lot of computational resources to process and to draw to the display. And so here's kind of a simplified version of what happens. You've got your 3D scene, and it has, which has your everything, all the points in space need to be calculated. And then you need to figure out where they're positioned in space. And then you need to figure out what textures are going to be there and like and where it's positioned in space. And then you need to actually go through the process of rasterizing, which basically is just actually for each pixel in your screen, deciding what color actually needs to be drawn to the screen. And yeah, like that's a lot to do. So the thing is that if your 3D models are really big, they can totally make your app crash and burn if you don't handle it properly. And the reason for that is because models can get really complex, and your devices, you can, like I said before, they only handle so much. And so you might ask yourself, okay, I'm new to developing for the Quest or to HoloLens. Tell me exactly how many polygons I can have in my scene at any given time. Short answer is it's not that easy to, I can't give you a straight answer because there's lots of different effects that go, or factors that go into performance and what makes things work well. But a general guideline that HoloLens said once to Buddy Rob on Twitter is that for HoloLens 1, try to get 100,000 polygons. But that's not, that's one metric that you can look at. And we're going to look at that right now. So polygons, that's the number of triangles that you have. So VR can typically handle more polygons than, say, something like HoloLens 1. Also, there is a HoloLens 2, but I'm talking about HoloLens 1 because that's I have most experience with HoloLens 1. So anyways, VR can typically handle more polygons than, like, more content than HoloLens. And so that's nice. But either way, so that's good to keep in mind. The problem is that not a lot of, or there's lots of 3D content out there. Like, look at this nice business district. Okay, you visit it and you're like, yes, I want to go and I want to go build my worlds, and I want to put these sweet assets into my scene. This is going to be super awesome. And oh my, but then, so you go somewhere, you have high hopes, you're like feeling really good. But the problem is that the 3D content is really big, and it's actually not even, you'll find a lot that 3D content that's out there, it's not even meant to be, it's not meant for game engines or for devices. It's too big. And so if you were to just add some of these models in without thinking about it and checking, your app could totally crash and burn. And it wouldn't fit. Like, look at this example that I gave you. 12 million polygons. That's total. And our maximum, say, in Quest, absolute max is 200 or 2 million. Way too big, right? And so you need to think about some workarounds of how do you get the 3D models to work, and how do you make it small enough? The workaround that you can think about is to do optimization for your 3D models. And optimization just means it's when you're reducing the number of vertices, like the points in space, and faces in geometry. And you can optimize things manually, or there's different tools like Simplygon is if you're interested in this, look up Simplygon, and you can have it automatically done. You could do it manually. And at the end of the day, there's always this tension between creators and developers, because the creators are like, let me just be the artist that I want to be. Like, they just want to make what they want to make, right? They don't want to think about constraints. And then the developer's like, oh my gosh, can you please just make something small enough for me? So there's always this like tension between creators and developers, because the creator wants it to be beautiful and awesome, and the developer's like, yes, I want that too, but I also want it to like be very performant and work really well. And the thing is that sometimes, even when you optimize your content as best as you can, it still doesn't quite cut it for your device. You might have business needs, like especially if you work in industry like architecture, engineering, construction, like those folks that are working in those big industries, they have giant files, right? And you can't cut it. Like, think about all of the detail that would go into building construction stuff. Like, there's so much detail. And the workaround, so what do software developers do about that? One of the ways that I came across this last year, which I'm pretty excited about, is streaming. Okay, so streaming is a really powerful, exciting technique to look into if you have big requirements. And basically what it is when your PC, your application, everything gets computed on a PC, like a big machine, and then all you do is remotely connect to your device, and you just tell so you do all of your business application logic on your powerful device, and then you go, hey, you just stream it over to your Quest, and then your Quest just displays it. So that's really awesome, because your Quest or any mixed reality device, it doesn't have to do any thinking. All it needs to do is just send the input data. So the process for that would be something like the device connects remotely to the PC through Wi-Fi. Then the device sends the sensor and input data to the PC. The PC processes everything, and then it just sends the pictures to the display. And So the device doesn't really have to do too much. And so that really takes a load off, and that really opens up your ability to work way more powerfully and fit more 3D content in. And so but sometimes if your laptop or desktop isn't that powerful, you can take it a step further and use cloud-based solutions. And so an example for that is Azure Remote Rendering. I'll put a link to that at the end. And basically, if you need to render something that's really beefy, really intense, you can buy like access to distribute or like to the cloud solutions, so you can load really intense stuff. So that way they're doing all the processing power, and then your computer or your device just displays it. But so the bottom line is that creators, they're constantly employing different methods to ensure that their app is immersive yet performant, because 3D content creates worlds, and that's part of the thing that makes you feel immersed, right? But also, as a mixed reality creator, you need to think about, yes, your content, but how can I present my content in a way that my app doesn't crash and burn? So that's one of the ways. Now we're going to switch gears. Something else that mixed reality creators need to think about is user input and output. Let's compare the two traditional ways of 2D input versus what's found in mixed reality. We've got mouse, keyboard, controller, touch. Like, those are the things that we've been familiar with for the last many years. And the traditional ways of output are through our speakers, like surround sound or headphones, and through screens, right, of all different sizes, from little smartwatches all the way up to giant 50-inch TVs or whatever. So that's how it is traditionally. And there's the design patterns that work well with these inputs and outputs are fairly well known. But what is it like in mixed reality? We've got hand gestures, voice, head tracking, controllers with motion sensing, like this one. We've got the head as a cursor if you're in HoloLens 1. In some devices, we even have eye tracking. And the various forms of output in mixed reality are the 3D space around us. That's super exciting. It's different. It's everywhere, and that's super cool. And also spatial sound, like if you know, that's closer to your head, so it creates such a different or a neat feeling. So having this new sort of output is pretty cool because it's spatial. It's in these inputs and outputs, they involve our bodies more. And so these new forms of input and output, they open up amazing possibilities of creating experiences that we can't traditionally do with 2D forms of input and output. So it opens up the world to us of new things that we can try. But when we're thinking about new ways of making experiences, a rule of thumb is, or something that I've learned, is that we need to really keep in mind the limitations of the devices that we're working with. So, because each mixed reality device, it has its own strengths and limitations. Like, for example, the HoloLens 1, it can track your hand, but all it can do is, and you can use your head, but for your hand, it recognizes this position, which is the ready position, and a tap and a hold. And that's it. That's all the hand tracking abilities that it has. HoloLens 2, on the other hand, it can recognize it's fully articulated joints, like it could recognize all of your joints, and you can do lots more things like full tap, or like it recognizes your finger. You can even use your hand as like a pointer. And so it's really important to keep stuff like that in mind. And the other thing is that these new ways of input and output have different levels of sophistication per device. So HoloLens 1 has voice recognition, and you can tell it to do commands, but that technology is still pretty new. And so it's a good idea to implement different ways. Like if you're really excited about voice, yes, implement something that recognizes the voice. but also make sure that you provide another way for your user to accomplish the same thing as a failsafe, because, you know, it'd be super annoying if you're like, I don't know, rotate, and it doesn't work, right? So also provide other multiple ways to allow your user to do the same thing and makes them feel pretty good. So one thing that you can do is, or what I recommend is, look at the target device characteristics first. Read the documentation. It's a really good idea to be familiar with what strengths and weaknesses are associated with the device that you're working with before diving into a project. And it makes sense that like some devices are better suited for certain mixed reality experiences than others. For example, don't go making a text-based adventure game in HoloLens 1. You'll make your users cry because all they can do is use their pointy fingers to go tap, 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 tap on a keyboard, and that would just be the worst, right? Don't do that. Also, tell me if you know what that game is in the chat, and I'll tell you later. And so instead, make interactions that complement the device. For example, HoloLens, it's good at Oregon Trail. Yes, you got it. HoloLens is really good at making applications that require you to be present in the real world around you, right? Like for factory assembly, like if you're assembling something and you have something in front of you and like you need to learn how to interact with it. Quest is very good at transporting you to different worlds. I have an anecdote for you. See, when I was hired at the job that I'm working at, my boss was like, all right, Karina, I've got this idea. What if we could make like a paint swatch visualization tool? So you look at your kitchen and you're like, hey, I want to think about, I want to see what this would look like if it were blue. And I was working with the HoloLens. I was just tired. I was like, all right, I'm going to tackle that. And so I worked on that for a few months. And then I realized after a while that HoloLens 1 is an additive display, which means it doesn't render black at all. Black is just see-through. But if you're working on a paint swatch app, you need blacks, right? If you want to look at black paint on a wall, you need black. And color fidelity for something like a paint app, if you're deciding what you want to paint, or like what paint color you're going to choose based on what you're seeing in your device, color fidelity really matters. And so I worked on that for a few months, and then after a while I was like, you know what, boss, this is actually not going to work. HoloLens 1 is not the one to do this because its color it's not accurate enough. And so that was fine, and that was a good learning experience. And now I know, okay, I really should have researched this more to figure out what HoloLens is really good at. And so if I were to do something like that again, I would be using like a Quest or VR or like a pass-through application, which is when I'll get into that later. So be aware of what's good with your device, because the best mixed reality apps, they fully consider the device's input and output, the strengths and limitations of each device. So the last thing that we're going to look at is guiding the user experience. So it's what do mixed reality creators have to think about when they're guiding the flow of how they want their users to go through it. They're thinking about how to, first off, user experience. To define that's the overall experience of a person using a product, such as a website or an application in our case. And it's especially thinking about how easy or pleasing it is to use. So as mixed reality creators, we want to create the best experiences for our users possible. So we need to think about how to fit and organize information into the display, how to use or guide the user through the desired flow. Let's look at how it is in 2D UX. You've got thing that's, it's interesting about 2D is that you've got the literal physical screen space that you're looking at. You know that nothing is actually going to come outside of your screen. Like this little cat, he's focused. He knows that the fish are only going to come from the screen. And that's pretty interesting. Like they know it's right from there. The user knows where to place their attention. But in immersive 3D user, or when you're in the space, you still have a 2D space in front of you, although it's much bigger and you might not have as much peripheral vision. But the difference is that you may need to face your focus in any 3-dimensional direction. You might even need to physically turn your head or move or rotate where you need to be. So the challenge is, and like look at this top left one in Super Hot. The guy is moving literally all the way around behind him because something is behind him and he needs to pay attention to it. So the more places that you have, like the more possibilities that you have to receive information from, the more potential there is to have confusion for your user. So the user depends on the creator to lead them to face the right way to experience the application as intended. So if you're in an app and there's something literally right behind you, if you're like, how are you supposed to know to turn around and face the opposite direction? That's up to us as mixed reality creators to guide our users to do that. How do we do that? How do we guide our users to experience our apps in pleasant ways? How do I actually tell someone that they have to pay attention to something that's right behind them? What's really neat is we can learn from the game industry to answer some of these questions, because 3D worlds in 2D screens, they have similar problems. Here in this Assassin's Creed game, like the person might need to look at something way over here. And so they need to think about also in 3D open world games, how to guide the user to experience what they're supposed to experience. And some techniques that 3D games do, they can use particles. And if you've heard of Ghost of Tsushima, this is a pretty cool one because instead of having an overhead map, they have a particle system where the wind, any way that the wind is facing, that's the way that you're supposed to go. So that's pretty neat. That's one way that 3D worlds solve this. Another one that you can that you might see is arrows on the edge of the screen. Like in Assassin's Creed here, it's probably hard to see for you, but there's little arrows that appear up in the middle of the screen. They're just directional and they just kind of show you like, oh, pay attention to this thing over here. And so when you face it, then it goes away. And another technique that they use is spatial sound, like surround sound. What if you're playing Call of Duty or something and you happen to have a surround sound system? You'll be hearing the stuff coming from whatever direction, and that might indicate to you where do you place your attention. So a really good example that I found in UX or in mixed reality that covers this is from this game called Young Conquer. So we're going to look at it, and I want you to pay close attention to look out for those techniques that I talked about. There's going to be little arrows. Watch how they use particles to guide the attention. And also they implement spatial sound, but of course we can't tell that today. So let's look at Young Conquer for a second. So we've got the look here buttons that you could see and see these particles, how they're floating in space, and the person is watching and following them. And then there's the little character And you'll notice that if ever the person goes too far from where they're supposed to look, then they get that indicator from the screen to look in the direction that they're supposed to look. And that's definitely a solution. Some people, if you find, you might notice that the pointers are like the look here button, it's in the space. And I think that's part of the reason why it works. I've seen some people on, I'm part of a HoloLens developer Slack channel, which you could totally check out. And somebody was asking about how to approach the arrows on the screen thing. And you don't want to, it's best to put it in, like, make sure the model is in the space and not on the screen heads up display style. You don't want to do that especially in HoloLens, because that tends to, I've heard that that's not the best practice. A good example for spatial AR, spatial sound in AltSpace, or AltSpace is a great example they do a great job with implementing spatial sound. And if you're in an event, like a meetup with a bunch of people who are avatars, it's really good because if you're really far away from the person, then you don't hear them. But as they get closer, or as you approach a group of people, you start to hear them. And the sound, it corresponds to the amplitude of the voices corresponds to how close you are, which is really great because that's how it is in real life. So AltSpaces in VR is really good. And they have a PC client as well. So if you want to check that out, you could probably get a good idea of what they do. So take notes from AltSpace. They're doing a good job. Another aspect to think about and to consider is the play size. So in HoloLens, your play size is this room that's around you. Everything you can pay attention to, you can put stuff basically anywhere between 3 meters, and that's good in HoloLens. But in the Quest or VR, in VR applications, you can choose to have your user be sitting in one place, or to have like a seated stationary experience, or you can have a play area. And so based on whether they're standing still or moving around, that dictates how you present the experience. Here, there's an example in Job Simulator. In VR, you can play standing up or you can play sitting down, and you can see on the left there the differences that they made to their environment when the person was standing. So the bottom line is, for when you're guiding user experiences, that the users, they don't know where to go. They don't know what they need to be paying attention to. So you need to think as a creator of creative ways of how to guide them in where to focus their attention. And so that's about it. In summary, when you're creating a really awesome app, you need to be thinking about performance. You're wanting to create amazing experiences. You need to fulfill business requirements. And so you need 3D content to build your worlds, but you also need to think about that relationship between performance and immersion, and be very mindful of optimization techniques and other things like streaming. You could take advantage of implementing streaming to get the most power out of your application. When you're creating apps, you need to pay close attention to the input and output capabilities of your target device. And it's a good idea to shape your app around those strengths. Like, don't do what I did and try and make color app for a device like HoloLens that doesn't do well with color. Take advantage of, or think really carefully about the device that you're working with. And the other thing that you need to think about is thinking about creative ways to guide your users in the 3D space around them so that they can have the time of your life. One last tip to give you is to check out the toolkits that are out there to help you in your endeavors. When I was working, or when I'm working with HoloLens a lot, which is made by Microsoft. Microsoft made a toolkit called MRTK, or Mixed Reality Toolkit, and they put a lot of thought into the topics that I've talked about there, and they've presented them, or they've made them available to us as developers. And like the toolkits, they've got lots of different common things that you might need as building blocks in your application. And they're pretty, like they look super nice. They are optimized. They've thought about the performance aspects, so they've made them as beautiful as possible. They've made them as optimal as possible. They've done all the heavy lifting there, so you don't have to think about that. And they've done lots of research on the user experience, and you can look up those as well. And so if you want to go and learn all of the stuff, I have some links, and I'll place them in the chat here. Okay, it's this entire slide, so get stoked. Oh, it's too long. But yeah, I'll put these in the chat here. And so I definitely recommend looking up some of the stuff if you're interested in mixed reality. Like you can read more about the Azure remote rendering with the solutions from the cloud. Check out Simply Gone. It's very robust. It's that free model optimization tool. So if ever you come across a model that you really want to use and it's maybe not the best, you could even if it is good enough, you could always just run it through Simply Gone, and then that will help you. Check out the mixed reality software, or the MRTK, Microsoft's mixed reality toolkit. It's super helpful, and it's even just great for learning about experiences or good building blocks. There's lots of information there. Check out, there's the Oculus docs there. Of course, there's more mixed reality devices than Oculus and HoloLens, but that's my experience. And you can find case studies of mixed reality user interaction design. And also if you're really interested in performance, a talk that I very much recommend is this. It's about how there's the game Superhot, and it was on the Rift. And it talks about the developers, how they ported it to Oculus Quest. And it's very dense, or it's very much like lots of things went over my head, but I learned so much. And so if you want to think, like have a really good in-depth talk or thoughts about performance and smart algorithms of how to make things work in XR, definitely recommend that. And one last thing I want to tell you about, this is like a very cool headset. This is called the Vario XR1. It's a pass-through augmented reality device. It means that, and I just want to show you this because this blew my mind when I first saw it. This is a real a real place, and the device, it has screens, so it's like VR, but it has cameras that capture your environment and then displays it to your screen that you're seeing in VR, and then it augments the space. One thing I really want you to notice here, which is super cool, is how I'll start it over. We might have missed it, but how the car, once the car it's in the space, there's light calculations and the shadows match. So it's super cool. The Vario XR1, super cool device. It's like state of the art. But one thing that makes it work really well is that it the latency, like what I was talking about, the latency between when the cameras capture the stuff, do all the processing, and display it to your eyes, it's indiscernible. So this is an amazing device, and I really look forward to seeing what they can do with that. It's also, it costs a pretty penny, but it's very cool. All right. Thank you. Feel free to reach out. And yeah, I'm on She Codes with Radiance on Instagram and Facebook. And yeah, if you have any questions, I'd be happy to answer them for you. Oh, can't hear you, Amy.
Hello?
Hello, there you are.
Here. Okay, cool. I was saying, thank you so much, Karina, for your super interesting session and sharing your experience and expertise in interfaces. It's definitely gotten me very interested and excited for this type of experience in the future. So if you all have any questions or comments for Karina, put them in the chat right now and we can talk about it.
Yeah.
Yeah.
And I'll share my links with you guys.
Perfect. Thank you. Right. If there's no questions to further discuss, I think we'll just end it there.
Yeah.
Karina, how can anyone reach out to you and like get to talk to you a little bit more about what you're doing?
Okay, so if you want to reach out to me, you can find me on She Codes with Radiance, which on Facebook, and, on Facebook and that was the wrong type, and Instagram. But also, if you want to send me an email, you could also send me an email, and I will share it with you in the chat here. And that's about it. Yeah, I'm totally super excited to talk about anything regarding this topic. So if you have any questions, please reach out. I really love it a lot. So yeah, thank you for your time. Thanks for listening, everybody.